This is a short demonstration of SaltStack Enterprise's ability to deal with development workflows. So you see we already have a Docker host that's present in our environment. And we'll actually just kind of jump over into the CLI to kind of take a look at what's there. We actually have a couple of SLS files that are already built for us to be able to kind of control these workflows. And then we also have a Git controlled environment with a pre-built Docker file. And we can kind of see what the overall build process for this is supposed to be. Just a very simple application that reads a base 64 encoded file and then tells us exactly what the result of that is. But so we'll jump back into the SaltStack Enterprise console and let's look at that first build state that we're going to run and see what the effect of this build process is. So if we look at the actual build.sls, we see that we have a number of steps here just to make sure that some of the initial stuff is present, and then actually run through some of the initial portions of that build process. So run the actual docker.build to carry that out, and then just ensure that no existing containers are currently running, and then start the new container. Wait for a second for that to take place. And then set the actual minion grain based on the very specific image that exists in our Docker repository, and then run a quick unit test. Essentially, just make sure that it outputs it works, which should be the outcoded message or the decoded message, and then we'll notify if we locate a test failure there. So let's run this build. And typically this should run relatively fast, but again, we sometimes need to kind of consider the fact that we are actually going through the entire process of creating a Docker image, mounting it, and creating some things. So in this case, I'll spend a second rebuilding the job to introduce the break-it function, which I neglected to do before starting the recording of the video. But so we have that done, and we can see that it's actually relatively fast to just kind of build these little jobs. We can actually see that that job has already finished, and so we can actually jump into exactly what that looks like. And looking at the high state here, we can kind of see the effect of this overall build process. And so if we are looking at the individual IDs, probably the most important one to us is essentially just seeing that we had no failures here. But if we look at the actual unit test ID, we can see that this completed successfully and we had a return code of 0. So we actually came up with the right message according to what it was we were expecting to see. And then finally, if we look at the configurable test state to notify on test failure, we can see that this state didn't run because the on-fail requirement or the requisite didn't change. So we actually didn't spot a failure, so there's nothing to respond with. So that being said, let's take a quick look at the next part. In terms of breaking this, we're just going to kind of simulate a developer interaction here where we might do something like changing ourselves from base 64 to doing MD5 sum, and then running this quick commit. Just to ensure that according to the Git repository, we've run through a commit that this has occurred, and so we have a breaking change that's being introduced to our version control, and so we can execute that job, and then finally after that we can kind of go back, and it again will take a second to run through this process. There is a little bit of a lag in the time that it takes for the database to receive the specific set of instructions, and then for that to be passed on to the salt master, and then in turn to be passed on to the minion to take place, the actual build processes and functions, again, because typically this is intended to happen over a relatively large number of hosts. So with that state complete, we can jump into the high state here, and we can actually spot really, really quickly the parts of this that experienced failures. And so we see the actual individual error codes and returns of exactly what happened, as well as some of the not failures in this case, but we can see the changes that we made as a result of this. And in fact, we're enumerating those diffs line by line and item by item. So we can actually look at the Docker file itself and make the observation here that it was changed. So we see that we're doing MD5 sum now instead of base 64. And so we can actually go in through, run this build now that we know that we've successfully broken the Docker file, that we've introduced some bad code here. And again, this will take a second to just kind of process, so we'll let it think about what it wants to do before we move on. In this case, because all of our jobs are API rendered, we sometimes have the opportunity to catch these things while they're in progress, and sometimes we don't. But either way, switching back and forth from any view to another view will cause an API data refresh, and so in some of those cases we'll catch that. So we can actually see right away that there was a failure in this state. So that's apparent and very immediate to us. And then we have the opportunity again to jump into either the high state or the summary views and kind of take a look at exactly what's going on in this part of the environment. So if we look at this breakdown, we see the number of changes that are present, and we see that specifically, again, the ones that we were looking at, that unit test, we see that we actually have a different return code that in this case indicates that the text does not match it works. And in this case, we also see where we have that configurable test state to notify on test failure that we actually do execute this. So this was not prevented from happening by the requisite. And so this could be anything like send a Slack message, send an SMS, do any of those things, PagerDuty or whatever we need to raise the attention that something needs to be modified by hand, that some interaction is required. We actually could then take this on to something like a beacon or reactor to fix that state automatically. But so in terms of what that looks like, let's take a look at the rollback state. Pretty much in this case, we'll just git revert head to erase the most recent change. We can certainly modify this. We could target individual commit numbers or whatever we need to do to determine what that signature is of what we need to carry out. So again, this is an example, but if there was a need to specify variable information or something like that, or direct input for specific build numbers or any of that, all that data is available to us. And again, we're setting that in the grains, and we'll make that observation a little later, that grain is being interactively set every time a new build is run. But so we'll carry out this rollback process, which will then kick off the ensuing build as well. And so in just a second, we should be able to make the observation, assuming that that's done. So I see that the rollback occurred here and we have one success. And so we can actually look back into the views and we can kind of see, make those observations about whether or not this took place the way that we expected. And so here we're looking at, we can see that the git revert happened the way that we expected it to. And again, it gives us all of the requisite text, identifying the things that were changed, pretty much the same output we'd see in the console. Or in the command line, I'm sorry. And then we can also look back through, we can see that the unit test itself succeeded. We have the return codes, the containers themselves started. We identify all of that ancillary information about, container IDs and things like that might be relevant. And so we're identifying here that the return code was 0 as we expected. And then again, if we kind of look down at the bottom, we see that notify on test failure did not occur because in this case, there was no failure to make it happen. So finally, in terms of kind of all of this, again, there is a considerable amount of customizable data here, and just to kind of show that we are using that custom grain setting for that specific build number, we have that ability to add interaction with that in any way that we desire. So if we need that to be part of the notification, or if we want to target specific build numbers as far as what's being mentioned or anything like that, we certainly have the flexibility there as well. Thank you.